Welcome back, everybody. So what we got today is your 1.1 through 1.3 review. So I'm just going to jump right in and start going through everything. Here we go. This is the review that you're going to see for your quiz tomorrow or the next day. So here we go. 1.1 to 1.3 review. Rewrite the conditional statement in if-then form and identify the hypothesis and the conclusion. An acute angle is an angle that measures less than 90 degrees. Again, you have some artistic liberty here, but if there is an acute angle, then it measures less than 90 degrees. Okay? Now, when I say identify the hypothesis and conclusion, this will be on the quiz. All I need is this. Underline the hypothesis part, which is your if part, and underline the second part, which is your conclusion. Okay? Please, 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 pretty please, double check to make sure you have if and then. I know that sounds silly. It drives me nuts whenever I have to grade these quizzes and I have to mark off points for the if and then not being there. Calculus is offered if you have already taken pre-calculus. Notice the ifs in the middle of the sentence. So, if you have taken pre-calc, then calculus is offered. Okay? Again, it's as simple as underline here, hypothesis, underline there, conclusion. Alrighty? Good stuff. Decide whether each statement is true or false. If false, provide a counterexample. A point may lie on at most 2 lines. Okay? So what they're saying is this. That here's a single point, and I can only draw 2 lines through there. Do you think that's true or false? Hopefully we're thinking that's false, because if you really want, I can just keep drawing lines over and over and over and over and over. Am I getting annoying yet? And over. So I can have more than 1 line going through there. In fact, if you really want, you could have an infinite amount of lines. So this is false. And yes, drawing a simple little picture like that, even though it looks all crazy and whatnot, that's good enough for a counterexample. The equation 2x minus 7 equals x, or 5 plus x has exactly one solution. Well, let's solve it quick. Subtract x from both sides. X minus 7 equals 5. Add 7 over. X equals 12. That's exactly one solution. So this is true. Alright? Not too bad. Numero trace. Write the inverse, converse, and contrapositive of the following conditional statement. If you like golf, then you should try for the golf team. Inverse is when you negate this. If you don't like golf, then you should not try out for the team. Okay? Man, is my handwriting bad. My apologies. Converse, you're flipping. Okay? If you try out for the golf team, then you like golf. Oops. Okay. Cool. Contrapositive, you flip and negate. So, we're looking at the converse. We're going to negate this statement. If you don't try out for the golf team, then you don't like golf. Okay? Cool. Again, I know I'm sounding like a broken record. Just make sure you're checking for if and then, making sure it's there. Hopefully your handwriting's better than mine, because this is horrible. So my apologies again, but shouldn't be too bad. Make sure you have this written down in your homework. Okay? Clearly have that labeled. It will help you greatly. Okay? Cool. Alright, now. Using P and Q below, write the symbolic notation, symbolic statements in words. The sky is cloudy for P. It is raining for Q. Little squiggly line means negate. So I'm negating this. The sky is not cloudy. Ta-da! That's it. You're just negating the sentence, okay? Or the statement. Here, with the arrow, this is when we do if-then. If P. If the sky is cloudy, then it is raining. Then it is raining. Okay? Wonderful. And lastly, it's the same thing. We're flipping this now. This is actually your contrapositive. If it is not raining, because of the squiggly, then the sky is not cloudy. The sky. Okay? Very good. Alrighty, on the back. Everybody's favorite laws of logic. Determine if statement 3 follows from statements 1 and 2. So we're going to read the first two, and then if we think it's true, we say yes and false, so on. Number 1, if an angle is acute, then it is not obtuse. If P, then Q. Angle ABC is acute. P is true. Therefore, ABC is not obtuse. Q is true. P, Q, P, Q. This is true by law of detachment. Okay? Good. Number 2, or part B rather. If you drive 50 miles per hour in a school zone, then you'll get a speeding ticket. Holy crap, please don't ever do that. That's horrible. Number 2, Daryl received a speeding ticket. Number 3, Daryl was driving 50 miles per hour in a school zone. Here's the thing. Read this in order. Just because Daryl received a speeding ticket, does that mean he had to be going 50 miles per hour in a school zone? No, he could have been going 5 miles over the speed limit. He could have been going over like 70 miles over the speed limit. Like it doesn't have to be this case. So this is the invalid one. And these ones are actually kind of easy to think about because it just doesn't make sense. There's got to be a counterexample for it. Lastly, if you are a teenager, then you are always right. If you are always right, then people will listen to you. If you are a teenager, then people will listen to you. See how we're crossing this one off? This is your law of syllogism. That's actually my favorite law because it kind of just goes like boom, 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 boom. And yes, I do say that in my head whenever I'm reading those. But it's just in order, okay? And it also kind of follows that transitive property. If A equals B, B equals C, then A equals C. Alrighty? Wonderful. Sketch the next figure in the pattern. I've got just 3 dots this way, 3 up and down. Then I'm adding a dot to the outside horizontally. The next one I'm adding dots vertically. So the next one I should add dots horizontally again. So I should have 1, 2, 3, 1, 2, 3, and just 2. Just be careful about that because, I mean, one thing I always get, if I've ever given this like problem in class before in years past, I see a lot of students that put like 3 on top and 3 on the bottom also. But notice it's just the one step. Here, I'm adding 1 to the outside. Here, I'm adding 1 to the up and top. So just keep following that set pattern. Number 7, describe a pattern sequence of numbers, predict the next number. 2, -4, 8, -16. So I'm doubling it, okay, like it's increasing. But notice that the sign changed from positive to negative, positive, negative. That just means we're multiplying by a negative value. So, multiply by -2. So when I do -16 times -2, I'm going to get positive 32. Alright, there's my description, there's my next number. 25, 36, 49, 64. If you would like, you could do this. Plus 11, plus 13, plus 15. So the next one should be plus 17. Okay? However, some of you have been saying this in class, which I'm very impressed by. These are your perfect squares. So you could just say that as well. I'm fine with either. Alright, it's still recognizing a pattern. So the next one should be 81, 9 times 9. Okay? Good, good, good. Cool. Now, final one. This one, let's slow down a little bit because I have some time. Show the conjecture is false by finding a counterexample. I want you to find a counterexample. So it says the square of the sum of 2 numbers is equal to the sum of the squares of the 2 numbers. That is, the quantity a plus b squared equals a squared plus b squared. This looks intimidating, but here's what I want you to do. I want you to just try putting in values. Meaning, Give me any real number is what I'm trying to say, like any number whatsoever. So I'm going to say 2. I'm going to let A be 2. All right? And then for B, I'm going to pick another number. 4. I just spaced out there. My apologies. So now if I plug this in, all right, the first side, the left side, is 2 plus 4 in parentheses squared. The right side is 2 squared plus 4 squared. And now I'm going to solve each side. Don't forget your rules of operations. 2 plus 4 is 6 squared. On the right side, 2 squared is 4 plus 4 squared is 16. 6 squared gives me 36. 4 plus 6 is 20. Does 36 equal 20? No. That's a slash through my equal sign. Here are your counter examples. Counter example. Okay? So, as you're doing that, just keep trying different things out. Alright? And when you do that, you might stumble across something that works. Now, I'll tell you guys, the only thing about counterexamples is there's an infinite amount of answers, which is good, but at the same time it can be a little bit intimidating because you might think, like, how am I going to get the right one? So, just keep trying, okay? And you're going to find out that it works out just great. Alright? And in conclusion, hooray! Get it? Garfield? Yeah, okay. Anyway, if you have any questions, feel free to ask, okay? And everything on here is fair game for the quiz, which you should kind of know by now. Make sure your homeworks are completed and accurate. And as always, very, very important, okay? Very, very important. Good luck. We're all counting on it.